Assalamualaikum and hi. I'm Aisyah and I'm going to explain about Bernoulli's theorem experiment. For the introduction, Bernoulli's theorem is stated as the total heat of a liquid flowing between 2 points remain constant provided that there is no loss due to friction and no gain of work between these 2 points. Bernoulli's equation is applicable to the steady flow of an incompressible fluid. It shows that the sum of the three quantities, which is pressure energy, kinetic energy, and potential energy, is constant. As you can see in the equation, the first equation, the left-hand side is for section 1 and the right-hand side is for section 2. Bernoulli's principle also states that an increase in the speed of the fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid potential energy. So this means pressure will decrease when the velocity increases. The continuity equation states that for an incompressible fluid flowing in a tube of varying cross-section, the mass flow rate is the same everywhere in the tube. So the equation can be written as rho 1 A1 V1 equals to rho 2 A2 V2. But since the density is constant, so then it is simply the flow rate, which is AV, that is constant. So the velocity of fluid is greater in narrower section as we apply the continuity equation. The objective of this experiment is to investigate the validity of the Bernoulli's equation when applied to the steady flow of water in a tapered tub, and also to determine the velocities of fluid flow. So these are the apparatus of the experiment, Bernoulli's theorem demonstration unit. It consists of manometer, test section, water inlet, unions, air blade screw, discharge valve, gland knife, hypodermic probe, and adjustable feet. So this is the procedure of the experiment. For general setup procedures, first we have to ensure that the test section has the 14-degree tapered section converging in the direction of the flow. The unions are tightened. And then the flexible inlet tube is connected using the quick release coupling in the bed of the channel. Then a flexible hose is connected to the outlet and directed into the channel. And next, the outlet valve is gradually opened to fill the volumetric tank with water. Then the water is allowed to fill in the manometer tubes until all trapped air is removed. And lastly, air blade screw is opened and controlled to get a certain volumetric flow. The screw is retightened when the manometer has reached a convenient height. So this is the experimental procedures. So basically, we have to make sure that all manometer tubes are bubbles free and the discharge valve is adjusted to high measurable flow rate. And after that, the hypodermic tube connected to manometer, which we label as H, is gently slide so that the cross section of venturi tube at A reach its end. So step 4 is repeated for other cross section, which is B, C, D, E, and F. So and then step 2 until 5 is repeated with 3 other decreasing flow rates by regulating the venturi discharge. Then we calculate the velocity, which is VIV, using the Bernoulli's equation. And also we calculated the velocity using the continuity equation. Then we find the difference between the two calculated velocities. So this is the result of the experiment. The volume we use is 3 liter and the time taken is 43.2 seconds. So from there we can get the flow rate using formula volume of water divided by time taken, and then we get 6.944 times 10 to the power of negative 5 meter cube per second. There are a few things that need to be calculated in order to determine the difference between VIB and VIC. So first, VIB we calculated using Bernoulli's equation, which is square root of 2g times total heat minus hi, and then area of each of the cross section A, B, C, D, E, and F we calculated to get the velocity VIC using continuity equation, which is flow rate divided by area. Same goes to the second trial. The calculation is repeated, but this time we have a different flow rate, which is 9.509 times 10 to the power of negative 5. For third trial, we have flow rate is 3.226 times 10 to the power of negative 4. From the experiment, it can be observed that when the diameter of the cross-section is smaller, the velocities along the distribution tube increases. The smallest cross-section, which is section C, gives huge pressure difference and has the highest velocity. the highest volumetric flow gave the highest velocity. This can be seen in the table result for third trial, where its velocity is greater than first trial and second trial. Using the continuity equation, VIC took area into consideration. So area increases, velocity decreases. Whereas Bernoulli's equation took pressure difference into consideration, where pressure decreases, velocity increases. So there is one negative value in the table result that should not be happen. So this maybe could be parallax error or air bubble trapped inside the tube. As Bernoulli stated, high velocity of fluid flow result in low pressure, and based on continuity equation, smaller area result in high velocity. Thus, the result prove both equations can be used to determine the velocity of fluid flow in manometer. Even the value is not exactly the same, but the pattern of increasing and decreasing at the converging and diverging portion is the same. The result of this experiment also proved the validity of Bernoulli's equation. So that's all for me. Thank you for watching.